using a new camera, so it's a little different, but it looks like it's going to work. Okay, let's get rolling. So today we're going to go over 5.6, which is special factorization. But before we get started, are there any questions from 5.4 and 5.5?
I have one from 5.5.
Perfect. Okay, let's get rolling. Oh, wait. Today we're going to go 5.6. Hold on, guys. Hold on. Okay, are you there?
Yeah.
Okay, what's up?
It's number 57 from 5.5.
5.5, 57, you said?
Yes.
The x squared minus x minus 12?
Yep.
Okay, I'm going to go over this two ways. Actually, it leads me into my first type of special factorization that your book really goes over, but I'm going to show you that you can work it both ways. Okay, is this Amanda?
Yes.
Okay, great. So I'm going to do the AC method way again. If you do the AC method way, you got to think of 1 there. Multiply those together, you get negative 12, right? And then you've got to find something that adds up to negative 1. Well, negative 4 times 3 multiplies to give you the negative 12, adds to give you the negative 1. Then I'm going to split it apart, and it becomes x. Now I'm going to use or x squared, actually, minus 4x, because that puts the positive 3x there. Are we good so far?
Yeah.
Okay. And then I'm going to factor the x out of the first term, and it leaves me with x minus 4, and the 3 out of the second term, and that leaves me with x minus 4. And then we've got the same thing in both terms. So we wind up with x minus 4 once I factor it out, and I'm left with x plus 3. Okay. So, Amanda, I'm going to smoothly transition from this question, though, over into special factorization. So if you have another question about homework, give me 2 seconds. But this is my first special factorization, because what's really nice, and it only happens if there's a 1 right here, okay? This doesn't happen if there's another number other than 1. We could do a much quicker factorization. Again, I'm going to repeat myself. Has to be a 1 here. It can't be like if you're looking at your book, number 59 or number 60, where there's like a 2 or a 3, okay? Has to be a 1. If there's a 1, you can automatically write parentheses and put 2 x's here, because we know, think of foiling this, x times x gives me x squared, right? And then all you have to do is think of 2 numbers that multiply to give you negative 12 and add to give you negative 1. Well, we found that already. That's negative 4 and positive 3. See how they're the same? Now, I wasn't being mean and not telling you this rule yesterday, because I'll tell you, this way of factoring works for any type of quadratic that is factorable, okay? It works for any type of quadratic that is factorable. But so if you're like, hey, I don't want to learn any tips and tricks here, Mr. Shirley, this will work every time, okay? And there's nothing wrong with that. But know that, like, later on, I'm going to do some quicker factoring whenever there's a 1 up here, just because it's quicker. And that's truly the only reason, okay? Okay, did you have another one, Amanda?
I guess number 19.
Same
That
section?
same section, yeah.
Okay. Yeah, number 19 is a good question. So we've got 2x squared plus 25, x minus 20, right?
Mm-hmm.
Okay, so we can't factor a 2 out. That was my first thought, because it'd be nice if we could factor 2 out. I'm going to distribute, so we get negative 40. Now I've got to find 2 numbers that multiply to get negative 40 that add up to 25, right? I'll do this on the side over here. So I'm going to think of 2 things that multiply to give me negative 40. We got 41, that's nowhere near close, right? The smaller number's got to be negative, right? Because when you add them together, it gives you that positive 20. So let's see, we got 20 times 2. That's not going to be close. It's not divisible by 3. 10 and 4. That's not going to be close. And then is it like 8 and 5 maybe? That's nowhere near close. Look, notice none of these add up to give me that negative or that positive 25. And I didn't do an example like this yesterday, but if that happens, this is considered a prime. I think they call it prime polynomial. Yeah. Prime polynomial. And what that means, it's not factorable. Remember, like a prime number is like 7 because you can't break it down into anything other than 7 times 1, right? And we call that, oh, that's prime number. Well, that means it's not factorable. So yeah, little tricky there. Any other questions? Remember, I'm not going to be here tomorrow. So that's the tough part. Now, I've already made the lecture for tomorrow. It'll pop up. I think it'll pop up after this class, actually. And then it'll be on 5-7, which is solving, which really, I'm going to tell you, solving these things is the easiest of the 3 sections. And then the test is already ready as well. So it'll come, it'll open Thursday again. It'll be open until Sunday, like the ones before. Okay, any questions before I jump in? I'm going to do a few more of these just to show you how these are a lot easier. But I don't mind going over anything right now. Because really, the bulk of this test, in a way, will be 5-4 and 5-5. You've got to know 5-4 and 5-5 to do 5-7. So it's one of those where I'm saying 5-7 is easy, but 5-7 is only easy if you know how to do 5-4 and 5-5. Okay. Solving these is not the hard part. You just set each factor equal to 0 and solve. That's not hard. You'll see it in the lecture. Are there any questions before I get rocking and rolling? Okay. Let me get rocking and rolling. So let's do one now. I'm going to choose some back from 5-5, actually. Let's look at, I'm going to do number 12 here. We've got 5x squared minus 45x plus 70. So, and the question will say factor completely, right? Factor completely. And the first thing, remember, the first thing I've got to factor is, this is still from 5-5. Okay, number 12. First thing I've got to do is see if something factors out of all these. Well, I know each of these numbers is divisible by 5, right? It either ends in a 5 or a 0. So I'm going to factor the 5 out first. And I want to do with x squared minus 9x. What's 70 divided by 5? Is that 14? I think so. So first I'm going to factor the 5 out. And then look, when I do this, it leaves me with this x squared by itself. So now I can do that easy factoring because I've got a 1 in front of the x squared. Okay. So then all I have to do is look at the 14 and think, what 2 numbers multiply to give me 14, add to give me negative 9? Well, I know it's got to deal with 7 and 2, but both have to be negative, right? 2 negatives make the positive 14, but when you add the 2 negatives, it gives you the negative 9. So in one step, I've got the factor, the 2 factors, I should say. Boom, I factored it. And again, this only works with a 1 in front. So if I gave you an example like 66 of 4x squared minus 39x plus 27, I can't factor a 4 out here, right? These two are odd. These aren't divisible by 4. I can't factor 4 out. I can't do this quick method because I've got a 4 right here and it's stuck. So I have to do the AC method. I'm not going to do the AC method on this one, but just know you'd have to do the 4 times the 27 and work it all the way out with factor by grouping, okay? So I couldn't do the easy method on this one because that 4 is stuck there. Now up here though, I could factor the 5 out, boom, left me with a nice trinomial with a 1 in front of the squared term, square variable, I should say. Okay, any questions, comments, concerns? Okay. So the first, really the main special factoring I'm going to go over because it tends to just pop up a lot. Martin Gay, Dr. Martin Gay is the lady that wrote this book, and then Dr. Blitzer wrote your college algebra book, and they just love this next factoring. I don't know why, but if you know it now, it'll just make a lot of like questions quicker and more streamlined. And it's called difference of squares. Okay, and we're going to see it pop up in other ways too. That's why I'm going to focus on it in this lecture. So the difference of squares looks like this. If we've got anything actually being squared, minus has to be a minus sign, okay? Something else being squared. Then we can write this as a, whatever is being squared, right? A minus the other thing being squared times a plus b, okay? So what's nice is we don't have to go through the like AC method. I can show you one. I'll show you one here in a minute. You can do the AC method on this one too if you're like, I don't like learning new things, okay? But we can do that, but it just makes our life a lot easier when it fits into this mold. I'll give you a very basic example here. We've got 4x squared minus 25, okay? 4x squared minus 25. I'm going to think like both of these are something squared. Okay, if I rewrote these, let's use a different color. I could think of this as 2x squared, right? Because you square the 2, that gives you the 4. You square the x, it gives you the x squared. Minus, we know 25 is 5 squared, right? So because now look, that's my A and that's my B, okay? So if we go back to the rule here, this is going to be 2x minus 5 times 2x plus 5. Now look, it has to fit a very specific scenario, right? I mean, difference of squares, like every single question you did, I believe in the last section, did not fit this scenario. It didn't fit a squared minus b squared, okay? So it has to fit a very specific scenario, and then we can make it into this, which makes it a quick factoring, okay? So I'm going to do this same one we just did, but with the AC method to show you that you're more than welcome to use the AC method. If you are just, man, I hate change, change is the worst, then you can keep your AC method. Remember that's 4x squared minus 25. Hold on, let's see if I can get this shot. Up here, it took that little bit of space, right? If I wanted to do this with the AC method, notice there's a missing variable in the middle. I have to create it, okay? And to bring something out of thin air, you have to make sure it's multiplied by 0. So this would be 4x squared plus 0x minus 25, okay? You have to have a trinomial to start this AC method. And then I'm going to do the AC method. So if you need to see another example of the AC method, if you haven't watched yesterday's lecture, you need to watch it first because it won't make much sense. But 4 times negative 25, so that's negative 100. But now we have to get two numbers that multiply to negative 100 that add up to 0, right? That's negative 10 and 10. Negative 10 multiplies to give me negative 100, but then it adds to give me 0. So I'm going to split the 0 apart now. 4x squared minus 10x. I'm going to group that together. Plus 10x minus 25, right? Now notice these two add up to 0. So we haven't violated any rules or anything. I can factor a 2x out of the first term, and I'm left with 2x minus 5. I can factor a 5 out of the second parentheses. I'm left with 2x minus 5. These match. So I've got 2x minus 5 times 2x plus 5, right? Hey, that's the same thing as we got up here. So even though I used the AC method here, which we went over extensively yesterday in yesterday's lecture, right? And you're more than welcome to use it. You just have to remember to put a 0 in the middle, okay? A 0x. And then you can use that. If not, like today, I'm going to stick on this difference of squares because it takes 2 seconds. And this is titled special factoring section, right? For a reason. So we're going to learn the special factoring. Any questions other than, okay, let's just watch a few of these so I can get the, excuse me, so I can get it down. Okay, let's look at another one. Let's say I've got, it's kind of nice when they give you something already squared. Like, let's say I had 100 minus y squared, okay? 100 minus y squared. I notice it's fitting into this mold, right? We've got the minus sign. We've got 100 is 10 squared, right? And then y is already being squared. So I can think of this as 10 squared minus y squared, okay? 10 squared minus y squared. Now, the first term is always what we write first in the parentheses. This is going to be 10 minus y, 10 plus y, and we're done. Okay, and we're done. And again, you're more than welcome to do that with the AC method. It's just going to take you a while. Just going to take you a while. Okay. Questions? Any questions while I just kind of keep rocking and rolling here? Okay. Let me. Let's see here. Yeah, let's look at one with a fraction. So let's say we've got 1 over 16 minus x to the 6. So that's a little different. 1 over 16 minus x to the 6. So we're going to have to remember the exponential rules here. Let me do that. So, we're going to have to remember the exponential rules with x to the 6, but let's go to the 1 over 16. Right? We need to think of something squared that gives me 1 over 16. Well, oh, shoot. Weird that I wrote it like that. It's going to be a fraction, okay? But now, what do I square to give me 1? Oh, I just need to put 1 here, right? 1 squared gives me 1. And then I need to think, well, what do I square that gives me 16? Oh, 4. 4 squared gives me 16, right? So if I come to a fraction and I need to write it as something squared, I just need to think of what can I square to get that part of the fraction. Well, 1 squared gives me 1, and 4 squared gives me 16. So I can write 1/16, or 1/4 squared is equal to 1/16. Now the x to the 6 is a little different, right? The x to the 6, remember when we square an exponent, we're multiplying it, right? So I need to think of what times 2 gives me 6. Well, x cubed would give me x to the 6. X cubed squared, I should say, gives me x to the 6. So this winds up being 1/4 minus x cubed times 1/4 plus x cubed. Little weirder because we're with fractions and we're dealing with weirder exponents. Okay. Questions? Comments, concerns? Okay. I'm gonna give you a few of these. I'm gonna steal them kind of from the book a little. Let's say we've got. I want you to try this one. We'll call it A and then B. 64x squared minus 49. I don't know if I have enough room. I might have to use another piece of paper. And then let's say 4y squared minus 1. I feel like this one especially pops up a lot. So I'm going to press pause real fast. I want you to try those. Actually, I'm not going to press pause because I'll just keep rolling. So try those real fast. Okay, so let's see if I can write this a little smaller, maybe. Okay, this first, oh, no, not 64, but 8, right? 8x squared minus 7 squared. So 8x minus 7, 8x plus 7. I'm getting the maximum usage of this, this piece of paper. And then let's go to the 4y squared minus 1. Well, I know 2 squared is 4, so 2y squared would be the first one. And 1 squared is just 1, right? So now I can separate these into 2y minus 1, 2y plus 1. Okay? 2y minus 1, 2y plus 1. Boom, shakalaka. Any questions before I just go to the next one? Give you a minute. Okay. Let's go to the, now the next ones look weird. They just look weird. They're not that hard though, but they're going to look really weird. Okay. Let's say we had one like this. I'm stealing this straight from your book so it doesn't look too crazy. This is number 18 on page 396. X minus 1 squared minus z squared. Okay. Now look, it's different because it's an entire binomial squared compared to all the ones previously, which were like a number squared, right? So instead of just a number or a single variable being squared, now we have a little binomial. But that's really going to be our a value now. So if we think of the whole a squared minus b squared, too fast. That's our a now. X minus 1 is our a, and z is going to be our b. So if we set this up, it's going to be x minus 1 minus z, x minus 1 plus z. Okay, that's it. We can't add anything together in these parentheses, and we're not multiplying out. Remember, the point is to factor them, to go from this subtraction to multiplication. Okay, and that's it. So I know it looks weird, and the answer looks weird because it looks more confusing than what we started with, but we're not solving, we're just factoring. Okay, solving is the next section, right? Solving is the next section. Okay. Guys, I'll go over the actually there's perfect square trinomials, but I don't want you to do those the easy way. So I'm going to put these in for homework, but the book goes over kind of it's not really a shortcut, to be honest with you. It goes over a shortcut method on how to or a special factoring on how to factor the perfect square trinomials, but I still want you to use the AC method or the quick method. So like 38, we've got x squared minus 18x plus 81. Look, hey, remember, we've got a 1 here. So we can do the quick form of factoring that we talked about earlier in this section. And then if we look at the 81, what times what gives me 81 adds up to negative 18? Well, it's negative 9 and negative 9, right? And then because there was a 1 in front, we could just plug that in. So it's x minus 9 squared. Done. Okay. See how this was a perfect square trinomial? So the ones in this section, they're going to turn out to be perfect square trinomials, but I don't want you really working them the way the book goes over them, because I find it more confusing to students than just knowing the AC method. So like for instance, if we looked at number, probably the first step, yeah. If we looked at number 41, I'm not 41, Jesus, 4, number 4 on page 395. We've got 25x squared plus 10x plus 1. So I want you doing this one just with the AC method, okay? Or if you know some other method, that's fine, just use it. I don't care. Doesn't matter what method you use. But we can't factor anything out, so we can't do the cool method over here that takes 2 seconds because we have a 25 stuck there, right? So I'm going to have to do the AC method. 25 times 1 is 25. I'm going to put it over here in this little shelf. What times what adds up to 20 or to 10 multiplies to give me 25? It's 5 and 5. That's how you know you have a perfect square trinomial, is these two numbers are the same. You see that? So anyway, we split this apart and we wind up with 25x squared plus 5x. That's going to be my first set of parentheses. Plus 5x plus 1. I can factor a 5x out of here, right? And I'm left with 5x plus 1. I don't want to change anything here, right? Remember, if I don't want to change anything because it already matches, I'm going to factor a 1 out. So I'm left with 5x plus 1, because if you factor a positive 1 out, nothing changes. And I don't need it to change because I already have a matching binomial. So I factor the 5x plus 1 out, and I'm left with 5x plus 1. Okay, perfect square trinomial. Now in this section, they're definitely going to label these as 5x plus 1 squared. Okay. So the first set of homework, I just want you to use the AC method or this little shortcut method. Either one's fine. But then the second part is on difference of squares. Okay. Any question? I mean, we've covered it today. 5.7 is not a long section, or 5.6, I'm sorry, is not a long section. And I've already made the lecture for 5.7, or right now I would just go into 5.7. Okay. Do you guys have any questions? I made the lecture for 5.7. I tried to find a lecture that I liked with a lot of YouTube people that I kind of follow, and they just don't. Everybody's different. Everybody's different, and it's not that it's a good or a bad. It's just, you know, the way I'm teaching you is not exactly how they teach factoring and stuff like that. Any questions? Okay, let's look at the homework. So homework for 5.6. I want you to do 1 through 21, and I want you to do all these. Usually I do evens, but there's not a lot of homework. So just 1 through 21 all, and that'll work. That'll cover what's going to be covered on the test for these special factorizations. So 5.6, it starts on page 395, 1 through 21